Hello friends, now in class 11th, I have told you about the stationary or the standing waves, and I told you that these standing waves are of two kinds, longitudinal and transverse. When they are produced in the stretched strings, then they are longitudinal, and when they are produced in the air columns, then they are longitudinal in nature. So transverse in case of strings. No doubt the longitudinal waves can also be produced in the stretched strings. There are the experiments. Actually this chapter is very long one, so this is taking very long time. You have to study the whole of the chapter very carefully from the point of view of your classroom study and also your NEET exam preparation. I am taking in both the cases. I have given the analytical treatment when the wave is reflected from the rare medium. If you take the reflected wave from the denser medium or the rigid medium, even you will get the same result. That we have to only prove that the distance between the two consecutive node or antinode is lambda by 2, and the distance between the node and the nearest antinode is lambda by 4. So until you have to see watch the full of the video. Until you watch it, you will not get what is inside the video and what have been said to you for the preparation and to learn about the matter of this topic. So this is necessary, and you have to like, share, subscribe to this video as to get it regularly. So students, now I am giving you a new topic related with this stationary wave, that is the vibration. That I am giving you first some definitions, and then I will tell you about the vibrations in the stretched string. So definitions are: definitions. Tone. Generally asked the tone, what is tone? So tone is whatever sound wave is produced by the in the stationary waves, that is called the tone. The frequency of stationary wave produced in stretched string or air columns, etc. is called tone. This is the frequency. Fundamental frequency. The minimum frequency. of wave. Produced in a string oblique air column is called fundamental frequency. Harmonics harmonics when frequency is integral multiple of fundamental frequency. It is called harmonic. Like first harmonic, second harmonic, third harmonic. Suppose we are getting the frequency which is the either even multiple or odd multiple, or suppose integral multiple of the fundamental frequency, then every frequency is called the harmonic. The fundamental frequency is called the first harmonic, the second frequency is called the second harmonic, third frequency is called the third harmonic, etc. Overtones. Overtones. The frequency more than first harmonic is called overtone. So it starts from the second overtone. The second overtone will be the first the second harmonic will be the first overtone, and third harmonic will be the second overtone. Octaves. The frequency that is double of fundamental frequency is called octaves. Octaves. You have heard in case of music, सा रे ग म प ध नि सा। से स्टार्ट होता है, से पे एंड होता है। सा रे ग म प ध नि सा। अब इसमें जो आठवां जो इसमें स्वर आता है, आठ एट्थ टोन जो आता है, that have the frequency just double of the first or the first harmonic or the fundamental frequency. Then this is called the octave. These are 8 tones, so they are called octave. And the frequency is in the increasing order. Suppose the fundamental frequency is 256. Then frequency 512, that will be the octave. So in this musical pattern, the first and last are in the ratio of 1 and 2. So this is what I told you about these definitions. Now I will take the vibrations in the stressed string. Vibrations in stressed string. There are transverse, stationary waves in stressed string. When vibrations are perpendicular to length of string. The speed of wave in string steady string V equal to square root of T upon where T tension in string, M mass per unit length of string. So this is your pi r square into rho. R the radius of the wire, rho density of material of the wire. So now I take when the string vibrates in a single loop. Let L equal to length of a string. So now I am taking the first this is so much, this is suppose we have this P and this is Q, this is so much long is the length of the string and it vibrates like this. It is the first mode of vibration. The length of this string is L. This length is L. You can say that this is the node, this is antinode, and this is node. So what we have that here we are having the two nodes and only one antinode. So this is the one loop. When a string vibrates in single loop, then you can have this lambda by 2 is equal to L or lambda equal to 2L. So how to find it? That between these two consecutive nodes, the distance is lambda by 2 and this is equal to L, the length of the wire. Lambda by 2 equal to 2L. Therefore, frequency N1 equal to 1 upon simple formula V upon lambda. N1 equal to 1 upon 12 into square root of T upon M. This is the minimum frequency. So this is called first harmonic. It is fundamental frequency called first harmonic. Now when this loop vibrates in two loops like this, this is P, this is now Q, this is node, antinode, node, antinode and node. Total length is M. The string vibrates in two loops. String vibrates in two loops. Then what we have? This lambda by 2 plus lambda by 2 equal to L. This is lambda by 2, this is lambda by 2, then this is equal to L. So this is your 2 lambda upon 2 is equal to L, or this gives lambda equal to 2L upon 2. We have not to cancel this because just we have to find the ratio. So the frequency N2 equal to B upon lambda. Then you put this value. N2 equal to 1 upon 2L, 2 upon 2L into square root of T upon N. So you can see that this frequency is double of the fundamental frequency. So this is called the second harmonic. And also you see that here the number of notes are 3 and antinodes are 2. So it is called second harmonic. Or first overtone. First overtone. Similarly, if suppose the same string vibrates in 3 loops like this. This is P, this is Q, this is antinode, node, and node, antinode, node, antinode, and node, and this is the length L. This is the third. Then what you see? That this lambda by 2 plus the string vibrates in 2 loops. The string vibrates in 3 loops. Then this lambda by 2 plus lambda by 2 plus lambda by 2 equal to 8. This is lambda by 2, lambda by 2, lambda by 2. So this is now your 3 lambda by 2 equal to L. So from here, this lambda equal to 2L upon 3. So frequency N3 equal to B upon lambda. N3 equal to 3 upon 2L into square root of T upon N. T upon N. This is called the third harmonic or second overtone. It is third harmonic or second overtone. Second overtone. So you can see that when the string vibrates in one loop, then this is 1 upon 2L, 2 loops, then 2L, 2 upon 2L, in 3 loops, then 3 upon 2L. The square root of T upon N is same for all. Here we are changing only to this figure. If suppose it has in 4 loops, then this is 4 upon 2L, 5 loops, then 5 upon 2L. So if suppose there are P loops, if string vibrates in P loops, then frequency N equal to P upon 2L into square root of T upon. Now this P 1, 2, 3, 4 and so on. So if you find the ratio of all these. Then you can have this therefore and 1 ratio and 2 ratio and 3 ratio and 4 ratio and so on, and this is equal to 1 ratio 2 ratio 3 ratio 4 ratio and so on. It means that in the steady string, the even and odd, both kinds of harmonic are produced. Thus, even and odd harmonics are produced in stressed string. This is why that the musical instruments which are having these wires, the sound produced by them is very melodious, because both kinds of your harmonics are being obtained. So our ear feels good when such kind of musical instruments are taken into play, like your sitar, guitar, etc. Now one thing you see, number of notes are more than the number of antinodes. What we have, that the nodes equal to A plus 1. A the number of nodes and the number of antinodes. Suppose node is 1, then antinode will be 2, and node is 3, then antinode will be 4. And in case of steady string, the nodes are always odd number. Number of nodes in stressed string are always odd numbers. Like number of nodes, even numbers, like 2, 4, 6, 8 and so on. Similarly, suppose there is only one antinode, then node is 2, and node is always formed at the ends. At the ends of stressed string. always nodes. Then you can see that this the ends for P and Q. Then we are having the node, and there are others also, but on the ends there will be always the nodes. So this you can find that the vibrations in the string depends upon the length and tension in the string, radius of the string, and the density of the string. The frequency of the wave in the stressed string depends upon number one, length, second, tension force, third, radius of string, and fourth, density of material of the string. Density of the material of the string. These are the four factors upon which this frequency depends. So this is what the vibrations in the string. So you all like, share and subscribe this. So many questions are asked from these the stationary waves in the string, and always remember that this is not necessary that always there will be the transverse wave in the string. There may be the longitudinal waves also, because the straight string can produce both kind of waves. When suppose this is your given the straight string, and I just pull it downward and leave, then this will vibrate like this. Then the wave produced in the string, that will be the transverse. And if suppose this end of the string is held in the hook, and this side in the some tuning fork, the tuning fork vibrate like this, then the waves can be produced longitudinal in this wire or in this string. So I have taken the particular case, but in both the cases the frequencies will be somewhat different, but the cases will be similar. There will always be the even and odd harmonics in the string. So you all like, share and subscribe this video. Thank you very much.